So thank you everyone for joining us today for the GCE's Slope Monitoring System Design and Implementation webinar. This is one of our series of Ask the Experts webinars presented by the Geotechnical Center of Excellence, which I should know because I work there. And it's about our geotechnical radar monitoring and slope performance monitoring courses. This is kind of a new thing for us by doing a webinar that covers 2 courses worth of content at once. The Geotechnical Center of Excellence, for anyone who doesn't already know, is a center at the University of Arizona, which is industry funded and member led. And that means that we are funded by a membership structure. We'll show what that looks like in just a moment. But we're an interdisciplinary center that kind of bridges the gaps between academia and industry across a variety of fields of studies. So that driving force of the industry, both leading us and directing where our research goes, helps make sure that our research is practical, it's collaborative with the industry, and it answers current real-world industry questions. I'd like first off to acknowledge our membership group, without which we would not be able to be here right now. So we have a tiered membership structure. The top 2 tiers are our voting board, but every single member makes a great deal of difference for us. And we also have associate members. If you are interested in the benefits of membership or interested in joining our members, please reach out to gce@arizona.edu, or I'm pretty sure we'll have that up in the chat as well momentarily. But let any of us know, and we'd be happy to discuss you becoming a member. As I mentioned, the material that we're covering today covers concepts from 2 of our courses. The first is our slope performance monitoring course, and that is a sort of comprehensive overview of all sorts of slope monitoring. So we've got small parts of that which are dedicated to radar, but in general, anything where we're looking at displacement, subsurface deformations, water or hydrology, we have modules for that in the slope performance monitoring course. And that slope performance monitoring course is underwritten by the Large Open Pit Project, and it's based on the book Guidelines for Slope Performance Monitoring. The second course that we're covering is our first course that we ever did, which is our geotechnical radar monitoring course. Now, this is a far more in-depth look at all things radar related to monitoring mines. So satellite-based, ground-based, SAR, INSAR, RAR, and it is presented, like all of our courses, by industry experts, some of which we'll be hearing from today, using real-world examples and case studies. Our GCE webinar team today consists of myself. I'm Benjamin Meyer, so I'm a software engineer at the Geotechnical Center of Excellence, and I'll be moderating today. James McNabb is our senior R&D engineer, and for those of you who have attended more than one of these webinars, you're probably used to seeing him. He's feeling a little under the weather today, so I'm talking for him. We also have Cheryl Bukowski, who is our professional development program lead. Hi, Cheryl.
Hi, everyone. Thank you so much for being here today.
And we also have Allison Bruzy, our program coordinator. Hi, Allison.
Hi, Benjamin. Hi, everybody. Glad you're here.
We also have members of our expert panel. First off, we have Paolo Farina, who's the managing director for GeoApp. Hi, Paolo.
Hi, everyone. Nice to meet you tonight.
We also have Bob Sharon, who's the director of Geotechnical and owner and operator for Sharon Geotechnical LLC. Hi, Bob.
Yes, hello, everybody. Thank you for allowing me to join you guys today. Looking forward to this discussion.
We have Charlotte Cooksey, who is the group geotechnical engineer for Rotec Mining. Hi, Charlotte.
Hi, everyone. Thank you for having me today.
We also have Zip Zavadny, senior geotechnical engineer at Zip Zavadny LLC. Hi, Zip.
Hello, everybody. Looking forward to our discussion.
We have Ray Yost, who's the principal specialist in rock mechanics for Tetra Tech. Hi, Ray.
How you doing? Should be a good talk here. I always enjoy these.
We have Priyanka Narshai, who's a consultant at SkyGeo. Hi, Priyanka.
Hi, everyone. Looking forward to the questions today.
And then we have Alex Newert, who's president of Canary Systems. Hi, Alex.
Hi, Benjamin. Hi, everybody.
I don't think we've got Serdar today, so moving to some housekeeping. First off, as a viewer for this presentation, you're muted and your video is off automatically. If you have any questions, we encourage you to use the Q&A function, which you can find at the bottom of your Zoom control panel. There will be a Q&A button. So at any time you can click on that, you can type up a question. You can choose whether or not that question will be submitted anonymously or not. You can also vote for questions that other people have asked by clicking that thumbs up icon on the question. And that will help us identify which questions are more of interest to the entire audience so we can prioritize which questions to answer first. Finally, this is a recorded webinar, and it will be posted both to our course sites, or for those of you who are not members of either of these courses, it will also be posted to the GCE YouTube page, which you'll see a link to in chat momentarily. And the posting to our YouTube page usually happens within about 48 hours of the actual webinar, so you should see that up sometime Friday. Also, of course, we've got a disclaimer. Please note that any views and opinions expressed by our panelists are their own and do not necessarily reflect those of the GCE or any affiliated organizations. All webinar content is intended for educational purposes only, and it is not intended to be a substitute for site-specific professional advice or analysis. Now that that's out of the way, I'd like to say thank you everyone for joining us, and we'll move right to our kickoff discussion. And first off, what do you think are the most critical factors to consider when designing and implementing a slope monitoring system? And this is open to the entire panel. I'll ask anyone who wants to just jump right in.
I can try to address this first.
Thank you.
So from my perspective, I think that first of all, when it comes to design, implementing a slope monitoring system, the most important points are the question to be addressed. Is the monitoring system supposed to be a safety critical monitoring system or simply an investigative monitoring system for strategic monitoring? These are probably the two main, let's say, points to be clarified at the beginning. And then the second point is what are the expected failure mechanisms that we may have at the mine site? So in terms of failure modes, but also in terms of instability scale that we may have. So are we expecting to have bench scale, multi-bench scale instabilities, or inter-ramp or overall slope instabilities? Because this, of course, may imply the use of different technologies and also may imply the use of different methods to analyze and interpret the monitoring data. So I think that those are the most important to me points. Of course, based on these, we can design the most appropriate monitoring program, selecting the different type of technologies that we have to include for surface displacement, for subsurface displacement, pore pressure, vibration. And this is probably the most challenging part, not trying to figure out how to optimize the different monitoring technologies that we may have today available on the market. Of course, looking at the budget, at the available budget, but also at the same time trying to address the needs of the monitoring we have used to develop the system.
I can go second, if that's okay.
Definitely.
Thank you. I agree with everything that Paolo said. That was such a wonderful introduction. And I think just to add one or two things, it's really very important to understand the technology that you're utilizing, what the advantages and disadvantages are of that particular sensor or set of sensors that you may have selected to address or monitor a particular area of concern, what the limitations are, and then how that feeds into a trigger action response plan, which forms part of the pit slope monitoring program. If you understand the advantages and disadvantages of your sensor and the limitations, it's incredibly important that that filters into the trigger action response plan, especially when deciding different levels of alarms or, the most serious levels, which are critical alarms and then evacuation.
To build a little bit on both of those, especially that first point that Paulo raised about what's the intended purpose of the monitoring system. When it comes to that safety critical piece, the information cycle time can be of interest. How long is it going to take to get monitoring results through the whole processing cycle and then sped back out? Sometimes you can do this very quickly. Sometimes depending on the instrumentation that you select or the total system, that cycle time can be quite extensive. And certainly considering that versus the speed of failure can be an important consideration.
Yeah, I'd just like to follow up on all of these very well put thoughts. The critical piece, and we've talked about that several times during this course, is understanding the failure mode. And Paulo touched upon it. That's extremely important, I think. The one item that hasn't been talked about is on the implementation piece. You have to get managerial and staff buy-in, if you will, and understanding of the system. Some of these systems are quite expensive, and it's very important to get buy-in both from the staff out in the field and the staff upstairs. The other items we've mentioned, the TARP, which is, of course, extremely important. And to develop a proper TARP, you need to understand the potential failure mechanism. Once again, understanding the failure mode. Is it going to be brittle? Is it going to be a protracted type failure mode? And to kind of follow up on what Ray said, the implementation to the monitoring data is extremely important. I have seen some operations that have these sophisticated monitoring systems, but there's really nobody watching after them on a regular basis. You have to have the proper staff, the staff trained in those systems, and also the staff needs to react to any type of trigger alarm. The worst thing that can happen is you have a radar system watching a slope and nobody is watching the data, which I have seen on a couple of occasions.
Oh, yeah. I've seen that one as well.
Yeah, I think all these are great comments. I agree with everything you said. I think it's particularly important, like Paolo started out, is you need to know what you're trying to monitor. What are you trying, what kind of information do you need to do to answer the questions that you developed when you designed the slopes in the first place? We need to understand the failure mechanisms. One thing that I would like to add to all the comments that have been made so far is regarding developing a baseline of monitoring. So this will help you to understand what the base conditions are. If, for example, if you have prisms monitoring the slope, you're collecting data on total vector movement, rather than just line of sight that you might get with the radar systems and LiDAR. As Charlotte pointed out, we need to understand what the capabilities and limitations of these instruments are. So collecting that baseline information, for instance, if you have prisms on the slope, you're getting the total vector. If you have, groundwater is important to you, you're getting an understanding of what the base conditions are that'll help you to understand what the groundwater pore pressure conditions are in the slope. And then, of course, the tarps are going to tell you what the exceptions are, where your movement is not the movement or whatever measurements that you have do not follow the pattern of your baseline information. So that's going to help you to understand what the anomalies might be. Are you reaching the targets, say for reaching dewatering and pore pressure targets in the slopes? So I think that it's important to get a feel for what your baseline information is. And that's why you like to get your monitoring instrumentation out there early for a developing project, or to try to figure out where the gaps are and get some monitoring in there. So all of these things will ultimately fit together. And then, of course, you have the benefits of what you might get from an integrated monitoring course. So that helps you to validate the data that you're getting by having multiple systems in place, having information out there from other types of monitoring to help you what the cause and effect of monitoring is, so that we understand what the context of changes in a monitoring pattern are giving us. And so I think that for more mature operations, having a system integrator out there to help you pull all of this data together and put it together in such a way that you can see what those trends are. And when you see the exceptions or the anomalous movement, you're in a position where you can make informed decisions based on reliable information that you can trust, because you're validating data as you go. So I think that getting that baseline established is really important, especially early on in an operation.
Bob mentioned systems integrator, so I think that was my cue to start talking. Thank you, Bob.
You, Alex. Hi.
Hi. To all of this relates to really what everyone else has shared as well. But I agree completely, Bob. Like, this is an important part of that process too, is knowing who the resources are that are going to help. Think about the mine planning process. Like to get a mine into production, the methodical steps and process and investment that's made to go from, a barren piece of ground to an open pit mine. I mean, the amount of capital that gets invested, the planning, the organization, starting with buying the land or securing leases, to developing, the geology and then planning all of the infrastructure and planning how you're going to get to the ore body and all the, related pieces that go into then, to then creating the mine. It's an amazing process that can take years. Now look on the risk management side. There isn't, in our view, there is not like an equivalent discipline to the risk management side. There continues to be a lot of like just shooting from the hip. Oh, hey, this thing might be moving. Let's throw a radar over here. Or, oh, let's drill a hole and put a piezometer in, without really like a real thoughtful, deliberate process to all of these areas that many of you have touched on, like identifying risks. Well, what do you do to identify risks? Well, you should be talking to your mine planning people. Where are the faults? What is the plan around mining? Like, how is that going to, intersect to the known geology? Look at some technologies out there that can provide guidance, like INSAR. INSAR is great. We love INSAR as like a planning tool. To your comments, Bob, about establishing baselines. So you can come up with 20 different places where you're worried about, instability or critical risk, but as it turns out, many of those will be quite stable. So how do you know that? Well, tools like INSAR can be really useful. Pay one of the INSAR providers to come up with a base survey, which then shows you where you actually have areas of concern. Instead of just like throwing stuff out on the mine because you think something might be happening in one place or another, look at technologies even for developing that baseline and evaluating where those expensive resources are best located. And then to your point about systems integrators, Bob, I agree completely as well. This is also one of our other observations, is that the mining business kind of goes up and down between wanting expert help and then trying to do things on their own. Mostly when they try to do things on their own, it just ends up being a waste of time and money and doesn't really deliver a whole lot of value. How many times I've been to a mine where the radars are not set up correctly, half the prisms aren't reporting, just in general, like there's a state of dysfunction to all these expensive assets that have been purchased and installed because there's no systems integrator, there's no expert resources outside the mine to really help make sure that once you decide on what your program should look like, how you're going to actually get it implemented, how you're going to support it. We're actually seeing this kind of trend. There was we've been in this business a long time. We went for a long time where miners weren't really doing hardly anything with risk management. Then they started buying a bunch of stuff, had trouble getting it to be valuable. Then they looked at like system integrators, and now we're kind of seeing it go back. We're kind of like seeing history like repeat itself, where a bunch of platform providers have come into the marketplace with advanced analytics tools, which is all well and good. I think that is the future of this business. But then now the mining clients are like, well, that's all we need are just these like analytics tools for data. Okay, well, where's the data coming from? Like garbage in, garbage out. Like you can have the most advanced models in the world, but if you don't feed it good data, you're not going to get a good forecast. And so we're kind of seeing this weird problem now developing. Many of our key clients are actually moving away from engaging us and other service providers and trying to do stuff on their own again because, they have Snowflake, they have some Power BI thing going on, or they're using Copilot. Okay, well, that's well and good. I do think those tools are amazing. We've done a bunch of pilot projects with these tools. I gave a presentation at SME couple months ago in Denver on the use of these tools. These tools are the future, but you still need good data in the tools, and you still need expert resources to help guide that process. Otherwise, you can have the most sophisticated AI tool in the world. If you don't feed it good data, and if you don't have experts sitting in front of that tool guiding how it's going to work, it just will not deliver value. And in our context, like it's managing risk. So that means you're not going to be managing risks very well, which means you're exposing your staff to health and safety issues, deaths, and you're exposing the company to serious operational problems. So all to say, we want to see more discipline around this whole process. Just like mine planning and developing a mine is a highly disciplined process, I would love to see like more discipline in the development and implementation of risk management systems.
Yeah, Alex, I'd like to follow up on some really great comments that you made, just very briefly. But the overall impression or observations that I'm making nowadays is that these the system integrators, like what you guys do, are very good. I mean, there's some excellent tools out there to bring data together so that you can see it all on a screen. You have the time interval that you're interested in. You can see the patterns of movement of water levels and so forth, and you get all this data in context. So we know the tools are really good, and some operations have really advanced their understanding of getting reliable information in context with other data. But I think a lot of the geotechnical people out there, the slope engineers at a lot of the operations are still continue to not really be able to utilize the power of the kind of information that they can get. For example, a lot of mining operations are still collecting only slope distance data, from their prisms. They're bringing prisms up, but all I see from a number of clients, not all of them, but I'd say maybe half of them, is that all they're showing us is slope distance. We're not getting the vector components. So one of the things that I ask them is that, okay, you've got all this wonderful radar data. The graphics look wonderful. You can see the patterns in color. That's all great, but it's still line of sight. So when I ask them, I said, okay, what's the total movement? They can't tell me. They have prisms out there, but they're not utilizing total vector or component vector data. Not a hard thing to do as long as your monitoring systems are functional. So, but they're afraid of the error that they get. And I said, don't be afraid of it. I said, if you've got it, try to figure out why you have it. Try to focus it better. And there are all kinds of methods that we talk about in this monitoring guidelines book as to how to improve the quality of prism data. Once they get that in there, they can start having at least some kind of a quantitative understanding of what the component of movement the operators are getting from their radars or from INSAR or any other type of instrument that's given them one-dimensional data. And the operations aren't doing a very good job of this, many of them. And so I've challenged them to go to their system integrator. Most of these big operations have a system integrator now, and challenge them to help the operations put together a system that gives them better visualization of data. And for guys like you, Alex, to ask the operators the questions. Well, what are you doing with your prism data, for instance? And the same thing about like putting piezometric data and rainfall data and prism data together with their radar data, so that they have a complete picture of cause and effect of the data that they're getting. The capabilities are there. The slope engineers, the guys on the ground at the operations in many places where they should know better, but they're just not doing it. So guys like me are out there to review their processes, and we keep asking the same questions over and over and over again. And I'm wondering whether, with half of the operations that I do business with, whether they're listening. It all sounds good to them when we talk about it, but then you come back a year later and they haven't progressed. So I challenge the mine operations guys or the mine operators to do this better, and to challenge the system integrators to help them to generate this type of visualization of data. I don't get much of a chance to talk to the system integrators, but here's my big chance now, is to challenge the system integrators to talk to their customers and say, you guys could do better. And here's some examples. Maybe if we bring the two together a little bit better, we could advance the state of the art. Anyway, just some general comments. And I know that guys like Zip and Ray would probably have lots and lots to say about this from their own experience. So we all share these things in common with what we see at the mine operations.
Oh, yeah. No, I'm trying to jump in there. You guys are actually bringing up an interesting point, too, that I see a lot of times, that it's not always about getting the newest, latest, greatest, fanciest, most visually, graphically compelling system. It's a lot of times it's fit for purpose systems. And all of these different systems, and I think Charlotte touched on this, they all have their pluses and minuses, their limitations and whatnot. So a lot of it is understanding, what you need to monitor. And sometimes you don't need the most sophisticated advanced technology to monitor it. I was actually just out at a project site building extensometers by banging two pegs into a ground, and that's going to be fine. that's not, we don't need a radar. We don't need all this other stuff. We actually can't put it there. Sometimes some of these older techniques are equally applicable. The other thing too that I see this, I'm going to pick on some of the technology folks a little bit. I love radars and I love what they can do, but they're also resource intensive. And you have to think about this balance of resources that you have to babysit all these systems, to take care of them. Sometimes if you're out there looking at, like, I'm going to put some prisms in there, put an RTS up, and that works pretty well, versus the resources that go into a radar. Can I get away with monitoring with just prisms, or prisms and some other redundancy to my system? So a lot of it is thinking about, again, I think Zip touched on this a little bit, not just the system that you're going to put in place, but how you're going to run it and what you're going to get out of it, and the ability to actually use all this data in a meaningful way. Like, what's the point of having a radar if you're not using the capabilities of the radar? Put something simpler in there that you might actually use a bit more. So I think there's a lot of really integrated thoughts in all of this discussion, with not just sort of defaulting to the latest system, but really thinking through what that system costs, what you're monitoring, what data is coming out of it, and then how you're going to actually use that data and communicate it back out to the people that need it.
Do you want me to answer some of that, Ray?
I was just going to say a small comment. Just a small comment on that, Ray, on what Ray, Bob, and Alex were saying. I think is also customization, right? And working with the client to figure out what do they want to monitor, and creating a solution with your consultants or your service providers to best fit what you are trying to monitor as well. And I think that's all part of that integration, incorporating other instrumentation all together to try and implement a proper, more usable feature or report or monitoring system for you and your site, and what works for your team as well. Yeah, that's just the comment I had to make.
All excellent points, but I think it all goes right back to the first point that Paolo was saying, namely, you have to understand the failure mode. And to understand the failure mode, you need to know the geology, you need the structural geology. So that's really the first and starting point. You need to understand what you're dealing with. You can have all these sophisticated systems, but if you don't have the structural geology right, you're semi-wasting your time.
Zip, I think just to finalize maybe this wonderful conversation is to draw it all the way back around to what is the design acceptance criteria, what's the FOS, what's the POF, understanding where that section line was cut, what were the results of the models and the analysis, and what is the design with risk component, because that's going to dictate the level of monitoring required for that specific portion of the slope or that instability. And it goes back to what we were saying, or some of the questions posed towards the radar service providers is, then you go into very detailed planning of how often are you reporting? Is it a hourly report? Are you doing daily reports, weekly reports? Are you just managing alarms as they come through? Or are you literally sitting in front of the computer on a 24/7 shift basis, watching that radar live? So I think, like Zip always goes back to, what is the failure mode? What is the situation? And then that dictates how it needs to be monitored from a personnel perspective.
That was a great wrap up, Charlotte. And I think that discussion, having touched on not just the idiosyncrasies and individual needs of different parts of each pit, but also the need for buy-in and the need to carefully develop your monitoring in order to set TARPs appropriately, leads in really well to our next question. And that is, how can we avoid becoming the geotechs who pride failure while we're learning and developing those alarm thresholds?
think a lot of that one is just setting expectations right from the get-go. As you're rolling those things out, you have to tell people that, hey, this is going to be a bit of a learning process initially. There will be areas where we have false alarms. Just be patient with us. The minute you set those systems up as this is going to be foolproof and then something happens, you're kind of setting yourself up for a lot of, well, not failure, but certainly failure of getting that messaging out.
Yeah,
I think
this goes back to what Bob was saying. Really understanding the baseline of the slope is absolutely fundamental. You need to understand the baseline movements first.
I think to add to what Sip said, there are a bunch of methodologies of looking at radar data specifically, but it applies to other sensors. It can be a database approach of information that you're collecting. It can be empirical. You could be sharing information with brother or sister operations who have very similar geotechnical environments. So there's a bit of a toolkit for being able to start setting alarm thresholds and really pick the brains of your service providers, because they know the equipment, they've seen a multitude of different geotechnical environments, and we kind of have a good inkling of where to start. And what I normally say in this instance, to build on what Ray's already discussed, is setting the expectations, explaining what you're doing. You're in a test phase. And typically, I wouldn't probably put on the critical alarms, for example, until I was really, really happy with the alarm thresholds or set of alarm thresholds below that kind of level. So it's building up and understanding the data, setting the alarms, and understanding then the alarm thresholds that are then applied and all the nuances that go with it. And it was actually Ground Probe, and Albert Cabrejo was the lead author on this paper. Sorry, Albert, I forget the exact name of the paper, but it was something fabulous, like an assessment of, I think, over 2,000 instabilities in the Ground Probe database, of which they looked at all the instabilities and the kind of similarities, even though the geotechnical environments were different, but from a data perspective. And they actually go on to give really good guidelines for setting generic alarms when you start with these kind of development of alarm thresholds and beginning to plug these into trigger action response plans.
If I can just add to this, I personally don't like the use of alarm threshold for the anticipation of failures. I mean, we should make clear to the geotechnical engineer on site that the alarm is supposed to identify anomalous condition is the monitoring data, no? Which not necessarily mean that we are forecasting a failure, no? Once you reach the first or the second level of alarm, unless we are dealing with very brittle failure at bench or multi-bench scale above a production area. In that case, we need to rely on automatic alarming to, let's say, evacuate the area, no? Because of course you may not have enough time for a geotech engineer to review the data and to take a decision. So you have to define a kind of automatic exclusion area. I mean, but typically, I mean, with the failure should be, let's say, identified or anticipated using more let's say, forecasting method like the inverse of velocity, or having an engineer reviewing the trends, not more than just relying on an automatic threshold. Of course, again, we assuming that the failure is developing over a time interval compatible, no, with the analysis done by an expert. And in general, when it comes to define automatic alarm capable of, let's say, evacuate an area, it's come to me the idea of defining an acceptable rate of false alarm with the operation. I mean, we should define, okay, how many alarm per week, per month, in your opinion, the production team is able to accept, no? Without losing trust in what we are doing. And then based on this, we can review the baseline, as Bob said at the beginning, so the noise level of, for example, velocity radar data over a significant amount of time, and define, okay, based on the statistics we got in near range, far range, these are the velocity threshold, now a combination of velocity and time interval to calculate the velocity and the number of minimum number of pixel, contiguous pixel to activate an area, which could be, let's say, acceptable, no, in terms of false alarm rate. That's how I typically try to address these issues with my clients.
I really like all of these comments. I think they're very good. This question or comment about, crying failure or where the slope engineer, because he's responding maybe due to some degree of uncertainty about what's going on with the data, is that he'll act on these alarms and maybe possibly overreact, but you can't be afraid to do it. If you see alarm levels being exceeded, you have an action plan for it or a TARP, you need to respond to that. So we are learners, and I have a lot of personal experience with this at a mining operation. I was the guy who was running the site's geotechnical program, and so a lot of us have been through this, and you learn from experience. When you're working in a mining environment where you do have slope movements and you have a close call or two, so you're getting some really good real life experience from this. I think there's a point in there where you want to run a trial of how your alarm system works. Are your TARPs really working? Do the people who need to respond to a TARP, do they know what they're doing? So it's a suggestion to help get past this learning curve and also to create awareness, for all of the stakeholders are out there or people who are at risk in an open pit operation where you have contact with potential slope instability experience, is to run a trial. Get your safety people. Safety people are probably the best ones to coordinate it, is to run a test of your emergency response system, where you have a trial of that a slope instability occurs. You've sectorized your pit so you know which part of it you need to close, and run a test of it. See how it works. I think that this is one of the best ways to get some good, solid experience of how an alarm system is designed to work, and who is out there who can manage the risks that are associated with people keeping people safe and so forth. So I think running a trial is going to be part of this process. This is just some comments that are supplemental to the great comments that we've heard around this question, but it's an important one. And all of us who deal with this in the real world have this experience, and you're trying to create a balance of keeping your operations safe, and also responding to alarms that may or may not be false. Sometimes we just don't know, and what we need to do is respond to them. So by having a trial of an emergency situation, just to test the system and see how it works, I think will create that level of awareness. People will understand what it means when you get these false alarms and how to respond to them. Or when the real one comes along, the real emergency happens, that people know what to do because you've tried the system. You've tried the system out and you see what works, what doesn't work, and you fix the problems that you encounter from a trial situation.
Bob, I just wanted to add something to that, and I'll be very, very quick, is when you're in this position of monitoring the alarms that are coming through, checking the trend plots, looking at the synthetic map, calibrating it with visual observation and such, it's actually a very lonely experience, and it can be incredibly scary because you have to make that call. And it's incredibly brave thing that one has to do when they do make that call and escalate it. And I think one of the most important things in a trigger action response plan is to have a redundancy per se of having a panel or a number of people within your organization or outside your organization, or even consultants at your beck and call if you're very lucky, whoever you need to support you in making these kind of decisions, because it shouldn't ultimately ever be left just to one person. That's cruel and unkind. So it's making sure that it's a team effort when dealing with everything that the panel's already put together and put forward, I think, which is just something else to consider.
Another piece to that too, and it speaks into this sort of trial and test that Bob was talking about, is you don't have to turn on the alarming function right off the bat. You can always, we've gone it where we've had this staged implementation where it's a small group of people and then a broader group of people and then finally site-wide, so that we understand, what's the rate of false alarms? Is it acceptable? How can we adjust this? I mean, it speaks right back again to that part of learning what the system is doing and about the environment it's deployed in. I like what someone said early on about, understanding the mechanism and monitoring appropriately. That's wonderful when we can do that. So often, though, it seems like and this was touched on earlier, we react. We just go out and get a system and implement it because something happened. And then if we go right into the TARP and alarming and whatnot, we're just sort of adding chaos upon chaos. Let's be a bit measured about this and take time to really understand what's happening before we start broadcasting this information out to the people that eventually we want to trust our interpretation. So we don't have to turn it on right away. We don't have to set, we can set the thresholds, but we don't have to broadcast that information out immediately.
I'm going to suggest that the statement actually provides the answer. So you ask, how can we avoid becoming the geotechs who cried wolf as we're learning and developing? So I think it's like self-explanatory. Like it must be a process of learning and developing. And I this is one of my observations. That's the part that kind of falls off the radar, no pun intended, at times, where just because you set the system up doesn't mean it's going to report reliably on what's happening. The process of getting it to work reliably must be a process of learning and developing. So, to your reluctance, Paolo, you said you said something to the effect of like you're a little afraid of these alarm thresholds, and maybe is that where you're coming from? Like, and I've observed this too. Like, if alarm thresholds are not part of a process of learning and developing, it's a disaster. I've been to mine sites where, I'm literally looking at the screen that they're using for monitoring their radar, and it's like flashing red every 8 seconds. Okay, well, that's not an effective risk management system. That's just a screen that somebody has to pay attention to every 8 seconds. So what's the learning and developing process there? Well, somebody should be looking at, hey, why is this flashing every 8 seconds? Maybe we need to adjust the boundaries of the alarm area. Maybe we need to adjust the alarm values. Like, what is actually happening? As opposed to just like getting stuck in this, like every 8 seconds, I have to go look at the screen. There must be a process of learning and developing. Anyway, is that where you're coming from, Paolo? Like, you'd rather see no alarms if there isn't a process of learning and developing, because without that learning and developing, it's just basically an unmanaged system. Is that what was happening?
Yeah. I'm typically start when at a site without experience, when they set up for first time alarms using radar. I try to simply recommend to start with a simple threshold based on the noise level of the data that we are collecting in the first periods, and then we learn from that. No, but again, it's important to have an idea of the mechanism on the different type of behavior we may have at the mine site, because we may have small scale failure, we may have large scale failure. They develop in very different time intervals. Okay. And the velocity associated could be different. So we have to be prepared to react quickly to small-scale failure very close to element at risk like production paths, while typically we have more time to and more deformation before failure for large-scale instabilities that can develop and of course have a long run out. So going behind the production path, now reaching the bottom of the pit. So what we have to do is to help the mine site staff to understand how to start with an alarm system, okay? And this is a learning process. And what is important is that to provide some basic elements for them to start to build on the first, let's say, period they are using. But they have questions to be addressed. For example, I'm dealing with a client who has some an instability detected by SIM extensometer. So they started to use a radar right now, but they are reprofiling the slope. So they closed the pit for the time being when the radar was reaching the site. Now the radar is on site, so someone has to take the responsibility to say, okay, what are the threshold? And that's what we are trying to say, guys. Let's start with some, let's say, threshold, basic threshold above the noise level. There could be some false alarm, but it's part of the process. Otherwise, the alternative is to keep the pit closed, which is, of course, different, not that having a few false alarm per week.
All right, awesome. So I think those were all very good points. We are about 8 minutes away from the end of the scheduled time for this webinar today. And I think we are going to have probably one other major question. Unless, Ray, did it look like you had anything else to add?
No, I'm good, thanks.
Okay, cool. So for the next question, which I think will take us all the way to the end, let's change tack a bit and ask, what are the most fail-safe ways to design the data transmission network for our monitoring systems? Our site is huge with several pits that are miles apart. So while centralizing the data to one location is great, such as the engineering or geotechnical office, it makes me nervous if comms go down for a pit. So where should the data go, and should it be addressed at one point or localized to each pit?
I think this is a very site-specific question, actually. I think it depends on the infrastructure of your pit, what your IT's capability is, what's your network looking like, do you have strong signal in the different pits, can you have individual stations set up for the different pits? I think it's very site-specific. I don't know what the rest of the panel thinks.
I can try to address this. I mean, there are different ways to get the data centralized, and of course, there are different ways to for the telemetry, to work. So, if the question is what kind of network we should use, probably I think we can try to approach the system with or a star topology or a mesh topology network, because this may somehow prevent to lose some of the data if there is a lack of connection between the central area and the data logger. So in this specific case, I would say that we could create a few mesh topology telemetry system that can be connected then with the central offices of engineering or geology. I don't know if this was the question, but there are ways to make a redundant system to avoid that the data are missed during the transmission, okay, because of a lack of connectivity. And nowadays there are a lot of very good systems like LoRa system that can help to get a long-range telemetry with a limited cost. So this is probably something that Alex can address much better than me.
I think maybe just to add from a radar service provider perspective, it goes back to alarms and trigger action response plans. So if for some reason the comms go down for the pit, you need to have a safety net alarm that if there is a large enough accumulation of movements based on the understanding of the slope and the failure mode, the alarm will be triggered. And pretty much, I'm going to speak on behalf of all of us, Reutech, Ground Probe, and IDS. We have on board strobe lights, sirens, all of that kind of stuff. So if you build that into the trigger action response plan, that if the sirens and the strobe lights go off, for example, that is a critical alarm and that means evacuation, you at least have some inherent kind of inbuilt strategy for if you do not have comms with that pit and there's a situation whereby something untoward is actually occurring. So that's just another part of a trigger action response plan that you can think about and add if required. I hope that helps.
Yeah, very, very well put, Charlotte. I think this goes back to the way we used to do it 50 years ago, is we actually had a extensometer across a rear tension crack, and using velocity ratio, normally we used about 1.5 to 2, that would automatically trigger a warning light such that we'd have almost real-time monitoring to that specific part of the pit. And if I understand this question, this person has multiple pits to work with, you have to have site-specific systems for those pits. And I think it needs to be site-specific for sure.
All right, that's awesome. So that goes right back to what Priyanka was saying, with it needing to be individually characterized for your mine site, but we do have some technological options for either redundancy or for an individual in the same pit alarm system. So we've got 2 minutes left. I don't think we've got enough time to bring up another question. So I'll take the chance to plug our professional development courses in general. You've just seen some links to these in the chat. So right now, all of our courses are currently $899 US with discounts for members and students. We have geotechnical radar monitoring and slope performance monitoring, which are the 2 courses that this webinar touched on. We also have separate courses for water and mine operations and slope stability, structural geology for geotechnical professionals, and also our newest one right now is fundamentals of open pit slope design. Later this year, we're going to be starting for the first time a course on blasting and pit slope performance. And all of our courses are presented by experts in the industry. So instead of a single teacher or a textbook, you will be seeing information presented from a variety of providers, a variety of mine operators, and you'll be seeing actual case studies that deal with each topic. And these are prioritized and shaped by our members. As I mentioned at the very beginning, we are industry funded and member led, which means we bring up new topics that are responses to what our membership currently needs and currently wants to know more about. All of these are self-paced from the date that they start. They run for a year. And we tend to have at least several of these live webinars where you'll see experts like those of us who have, well, not us because I'm not an expert, but everyone else that you can see on your screen. They're experts. But they gather together to help discuss topics in the subject and share that information with you and answer some of your questions. And let's see, I think that is about it. So I want to give one last really big thank you to all of our panelists and also to all of our participants who have joined us today. We've loved having you here, and we will have this up on our YouTube site in about 2 days.
Good chatting with all you guys. Nice to see you.
Yeah, take care.
Thank you very much.
Likewise.
Great talking to you today.
Thank you, Benjamin. Thanks,
Thank you,
everybody.
everyone.
Bye.
Great conversation.
Indeed,
you
it
very much.
was.
Really nice to be present. Bye-bye.
Bye. Thank you, everyone. Have a great day or night or afternoon or morning, depending upon where you are. And I'll close it out. We'll see you next time for a live webinar by the GCE.